Okay, so again, today we're going to spend the first half of class reviewing. I'm going to answer any question you guys have, go over all the topics, touch base on what you're still not sure about. We'll take this first half to review, and then the second half we'll take this the test. Again, the test I'm going to try this first time to do it through myAP. So when you log into myAP, you can go to Classroom. You guys, I think everyone's on my Classroom section, right? You guys joined. I think you all are. So I'll send it out to you guys. It's there. You'll open it. There's a 45-minute time limit on that quiz or test for us, and then it'll cut out. But when you're done, I'm pretty sure it'll show you your answers right away. So you'll submit it, the scores will go, and it'll grade it. And then the answers will show up so that you can review, like, oh, crap, I missed this one, or like, oh, I got them all. But that's what I'm going to use for this first test. We'll see how that goes. The reason I'm doing that is because those questions are from AP. You guys are in an AP class. Almost all of you, I think, are going to take the AP test. So I wanted to make your assessment as authentic as possible. For this first one, I'm only doing the multiple choice. I'm not doing the free response part. We're going to try to see how this goes, but again, I chose it because it's going to be the most authentic, because it's from AP. So that was my kind of rationale for this. Any other, I guess now we'll switch gears. Review. What do you want me to review? What do you want me to talk about? Huh? Oh, I have no idea. Those have probably been there for years.
What John wants to talk about.
Guys, can I have you put your phones away, please? Again, I'm taking this time. I'm here to help you review, answer any questions. Or are we feeling like, actually, we got it all, like, let's just take the test? I'll let you go test right now if we're all golden, but I don't think everyone is. So what questions? You want me to explain graphing again? I need you guys to give me input. What do you want from me? Otherwise, I'm useless right now. Tell me what you want me to review.
But I don't know where to start.
That's maybe not so great. I guess we can try and do an overview and see how that goes. So what are some, I guess, key terms? Speed. What was speed?
Velocity.
No, those are two different things. They're similar. What is the speed of an object? What's my equation?
Man, I remember talking about this, but I don't remember what
Yeah.
it was.
Delta x over delta t. How far you went in a certain amount of time. Think miles per hour. I went this many miles in 1 hour.
Going 17 miles per hour.
Yeah.
I think you would go
1 hour, good. Someone said velocity. What? I don't know. Velocity.
That's what you want to test. How many questions did you say were on there?
I think it's about 16. 16 multiple choice. I thought you said 11:30. Oh, shoot, it is. What was I looking at?
Do you want this or?
I'll
You must consume it. You must demonstrate physics with that piece of paper in order to.
When you come in, I can help you review whatever you need. We'll get that taken care of. So yeah, whoever your ISH teacher is, just let them know and come down whenever today.
All right.
Thank you. Appreciate it.
I'll be here the beginning of IH or whatever.
ISH?
Yeah.
Okay, yeah. Come down here anytime you can, and I'll work with you.
All right.
Bummer.
Imagine missing our review.
I know. And the time block includes lunch. So I was like, oh, you'll go right in the middle. Well, no, that's not the middle. We started at like 11:20. What's different about these? They're very, very similar.
Velocity is positive.
What's this guy?
Direction.
The vector. Right? This is my displacement. This is just a change in position. Actually, typically there's other, I'm going to just write distance. Some people write it D, some people write it as S. Distance over time. Right? Velocity is a vector. I go from here to there in a certain amount of time. I have a magnitude and a direction. So this could be S. A lot of times they just use an S. This is velocity with a vector. Right? So we get that. Speed is just how far you went. Like literally how long did you travel and what amount of time. Technically this is average speed. Because it can change. Velocity is a vector. But at any point in time, whatever speed they catch you at is technically could still be illegal. But anyway, that's velocity. What was the next term that we looked at? What was the progression?
Acceleration.
Yes, okay, I want to point out one thing. Technically, this is average. This is displacement from starting position to ending position. Well, I could walk really fast, then slow, and get to my ending position. And if I calculate it, that's actually an average. True velocity is technically instantaneous. You would calculate at a specific point. If it's constant, it doesn't matter. Average and instantaneous will always be the same. But this is actually the average velocity. Now, what did we do? Acceleration. If we do just a simple calculation, we have to assume it's average. If it's constant, our average and instant, they're going to be the same. It's a vector, right? The acceleration has a magnitude, but it also has a direction. Am I speeding up or am I slowing down? Your acceleration is a vector. What is acceleration in general terms? Describe it to me. If I get on the on-ramp to the highway, I stomp on the gas. I'm accelerating, aren't I? What's happening? Speeding up. My velocity's changing. Acceleration is a change in velocity. A change in velocity over time. Right? If I calculated, I started at 5 miles an hour, I ended at 10 miles an hour, and it took me 5 seconds to get there, I could calculate it, but it's only an average. If it said, calculate the constant acceleration, if it tells you it's constant, then you could say, sure, the average is whatever, but at any moment in time, it's also that, because it doesn't change. So we talked about acceleration. Acceleration is a change in velocity over time. What are the units of speed? We use metric units. A distance over a time, meters per second. What are the units for velocity? Trick question. Meters per second. All velocity is speed, but indicating what direction that speed is in. That's the only difference. They are different. If it asks you speed, you will not tell me a direction. Speeds don't have direction. If it asks for a velocity, you need the magnitude and the direction. Okay? Acceleration. What units do we have for acceleration? Velocity, we said, was meters per second. Time is seconds. There's our unit for acceleration. Right? Those are the three big, I guess, terms or concepts that we talked about. Now, let's go to our graphing. Remember we did a lot of graphing? What is this? What kind of graph have we got?
Distance over time.
Yeah, this is distance, right? This is just position. This is time. Here's our position time graph. My position over time looks like this. Well, that means my position, I get further away from zero as time goes by. It's steady, isn't it? Slope is rise over run. Right? If I want the slope of a position time graph, I would do rise over run. Well, the rise is position. The run is time. What do we get when we take the change in position over the change in time? What do we just define? No, this is displacement. That's the change in position. When your position changes with time, what's that called?
Speed or velocity.
Speed or velocity. If we don't have a direction, what is it?
Speed.
Speed. If I told you the direction in addition to this, what do we have? Velocity. They're different. Almost the same, but different. So that's technically would be, we can do V average. Because we could say the direction's in the positive x direction. Right? What was the other graph we did? What's the next graph we learned about?
Velocity over time.
Yeah. We said, okay, we could figure out velocity. Well, let's figure what that is over time. Time in seconds. This is velocity in meters per second. If this was our position time graph, what does our velocity time graph look like? We just said the slope of position time tells us how fast the position changes with time. That's velocity. Well, if we had a constant slope, which told us what the velocity is, how would we plot that? What would the plot look like? Yeah. Maggie went like this. She said just straight across. Right? At any moment in time, this slope is the same. At any moment in time, my position is changing the same for every amount of time. That means my velocity is exactly the same. Slope of position time is the velocity time. What would the slope of velocity time tell you? The slope of a velocity time would be the change in velocity over the change in time. Right? Rise over run. What's defined as the change in velocity over time? What term? We just talked about it. Acceleration. Acceleration is the change in your velocity over time. So from here, I could draw an acceleration versus time graph. What would this graph look like? If the slope of our velocity time graph tells us how the velocity is changing with time, that is our acceleration. Well, what's the slope of this graph? 0. The acceleration, the change in velocity over time, it doesn't. There is no change in velocity as time goes by. So I literally will plot 0 the whole time. Does that make sense? You remember all this? Here's a question. What is that? The area under the curve for a velocity time graph. Yes. You remember that? Remember why? You can just do your units. If I ask you what's the area under this curve mean, you're like, oh, flip. I have no idea. Well, shoot, I know how to do an area. My length times my width. What's my length? It's 10 meters per second. So I need to do 10 meters per second, right? Length times width. That's my length. What's my width? 10 what? 10 seconds. Okay, I'll do my math. Quick, what's 10 times 10? 10? No, it's 100. 100 what? Your units are very important. Meters over seconds times seconds. Meters. Wouldn't I get, meters times seconds over seconds if I did my fraction multiplication? Well, it's the same thing. That's what this is. What does that mean? What's the significance of the area under this curve being 100 meters? Hint, use your units. What do we measure in meters? The sky? Is that what someone said? Distance. Specifically, it's displacement, which is just final minus initial. I can know my total displacement for this amount of time was from 0 to 100 meters. I displaced 100 meters, according to this graph, by just doing the area under the curve. It's 100 meters, my units work out, boom. This is displacement. Right? Did these make sense? It'll be important to know, to be able to go from position time to velocity time to acceleration time. Position time to velocity, find the slope and plot that slope. Find the slope, plot that, you get your acceleration. This is a key when you do the the area under the curve of a VT graph. It actually tells you the displacement that occurred. Do you remember that? The last thing that can sometimes be tricky, we did an example. Let's say my VT graph. I want This is my velocity time graph. I want to know what's the displacement. How do I figure that out just from the graph? Yes. I want the area of this triangle. What's the other triangle I want? This? This?
Yeah, that's
Yes.
negative.
Area under the curve, I go from my curve down to my origins. Well, wait, my curve is below the 0 point. I got to go up to it. Do I add these two areas together?
Yes.
You do. It's correct that you definitely add them together. What's the area of this? Area equals of a triangle, 1/2 base times height. What's my base? 5 seconds. Whoa, that's terrible. What's my height? 10 meters per second gives me what? 50, 25? 25 what? Meters. Just do your unit analysis. How about this guy?
Same thing with negative.
Yeah. No, do it from scratch. He said same thing but negative. You're right. But make the math work for you. 1/2. What's my base? 5 to 10. That's a total of 5 seconds. 5 seconds. What's my height? -10. The math will work for you. 1/2 times 5 times -10 gives me -25 meters. And John's absolutely right. I add my area under my curve to get my total displacement. So what's my total displacement? Right? These can be tricky. It kind of makes sense though, right? I was moving in a positive direction, positive speed, and then I slowed down. I eventually stopped, right? Then I started increasing my velocity in the backwards direction. In order to do that, I got to cover some distance and then retrace my steps. Well, it's symmetric, so I literally started and ended at the same place, so I have no displacement. Displacement is final minus initial. From start to end, I didn't do anything in terms of my position. So I wanted to point this out because the area under the curve can be a little weird sometimes. It can be negative. Right? Do we remember your equation sheet? So one, you'll always get to use this on any test or quiz and the AP test, right? We have those, it looks like the first 3 equations were the ones that we used. So you guys will get to use this on your test. Problem is you need to know how. So what's one example? Let's do something from the baseball lab. Right, let's do some of them on the backside. Did everybody get a chance to finish that backside? Or try it? I know it helps a couple of you guys. I wanna do one with you. Let's do number 4. Number 4 says, suppose you throw a ball at an angle and it hits the ground 6 seconds later and 36 meters away. threw a ball at some angle. It was in the air for 6 seconds, and then it hit 36 meters away. First it says how high in the air did the ball travel? Well, how do we figure that out? Let's look at our equation sheet. First of all, at what point in time is the ball the highest? It's kind of a tricky one to think through. At what point in the motion is this ball the highest? In the middle. Right? So I want to calculate at what time? What time is half right in the middle?
3 seconds.
3 seconds. That's a conceptual understanding that you guys have to know. If I throw it from the ground and it takes 6 seconds, well, it's going to go up, stop for a moment, and then start to come back down. Both sides are going to be even. So I need to find at t equals 3, what's that height? Well, how would I do that? There's actually 2 steps. The first equation that you'd look at and see like, okay, I want to know the height. This equation makes sense to me, right? I know the time that I want. I know gravity's acceleration. That acts in the y direction. I want to know how high it went. Well, it started at 0. I want to know this. Oh, crap. I don't know the initial velocity. Shoot, how do I figure that out? Is there another equation we could use? Look in your equation sheet. I'll give you a hint. We can use this equation. If I go, what's gravity's acceleration in the y direction? Always. We're going to approximate it as -10 meters per second squared. What time am I calculating at?
3 seconds.
3 seconds. That's the point in time that I want to know. My initial velocity, that's what I need to figure out to plug in here. Vy initial. What's my velocity at that moment in time? In the y direction. When it reaches that peak, how fast is it moving in the y direction? It goes up, hits that point, and then it starts to come back down. What happens at that point? The peak. Come on. What is the velocity in the y direction right at the tippy top? It's going up, 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 and then somehow it needs to start coming down again.
So it hits 0.
It hits 0. It has to stop for a brief moment. So it stops going upward and it starts coming downward. That stopping point is right at the peak. Because right after that, it starts to fall down. So this, we know, is 0. At t equals 3 seconds, the ball is not moving up or down at all. It stopped for a moment. Right after it, it's going to start picking up speed and fall back down. Well, I can solve this. My initial velocity was then what? Right? My math, I get -30 meters per second. Because my seconds cancel out. Pull that to the other side. Boom. Initial velocity in the y direction was 30 meters per second. I'm going to plug that in. I want to know how high the ball went. It started at the ground. Started at 0. My initial velocity was 30 meters per second. I'm looking at 3 seconds. Velocity or acceleration due to gravity, -10, and then I have 3 squared. Right? Then I just do my math. Right? This is 9, -90, -45. This is +90. +90 minus 45 gives me 45, doesn't it? Oops. Does that make sense? A lot of times, if you're not sure what equation to use, look at what you know. I knew time, I knew distance, right? I knew starting height. I didn't know any height. Just look at what you know and see, like, oh, is there an equation where I'm only missing one variable? That one I can use, get that. It might be the variable that I'm being asked about. Sometimes you have to do 2 things to get to the answer that you want. I couldn't solve this equation because I didn't know the height and I didn't know the initial velocity in the y direction. Right? So I had to do this first to figure it out, then plug it in and solve for what I want. Again, a reminder, those equations, they're written in the x direction. Well, that's great. We just said the same thing applies, but in the y direction. So you change all the x's to a y. Right? Physics works the exact same in the x direction as it does in the y direction. They're 2 independent directions. We solve them separately. Do you remember how to find like total velocity? How fast this was launched? Do you remember how we did that? Sometimes it's going to ask you, what was the initial velocity of this launch? That's the velocity I want. Well, I calculate the velocity in this direction and then the velocity in that direction. Don't I do Pythagorean theorem? Right? This is A, B, C. I do A squared plus B squared equals C squared. So this is, it's just algebra. So be careful. If it asks you for the initial launch velocity and you launch it at some angle, you need both components. Now, if I launched it straight up in the air, it's only the y velocity. So I just calculate my y velocity. If I launched it straight out, all of my launch velocities in the x direction. So just calculate the x velocity. But if you launch it at a certain angle, you have 2 components that you calculate independently. And then you make this triangle and see, okay, what was the actual speed that I threw the ball at? Do Pythagorean theorem. Does that make sense? So that was kind of that physics, or that, excuse me, the baseball lab we did, projectile motion. Does my x velocity change throughout the motion?
Yes.
You sure? Does my speed in the x direction change?
Yeah.
We neglect air resistance. We're assuming that air resistance doesn't slow anything down. So when I throw a ball, gravity doesn't act in the x direction. There's nothing affecting the ball in this direction. So my velocity in the x direction is the same throughout the whole motion. My y velocity changes. Gravity is always accelerating my object down. So it's always changing my velocity in the y direction. You guys remember relative motion? Right? If I'm running 5 meters per second on a train car, and that train car is also moving at 5 meters per second. Well, every second the train moves 5 seconds or 5 meters, and I move 5 meters on the train car. So I add my velocities up and say, oh, I've moved a total of 10 meters in that 1 second. So my relative velocity from looking outside is 10. Josh?
When are we supposed to start our test?
Like nowish.
Okay, I was just making sure.
Yeah. I knew I was close. I was trying to fit stuff in. But yeah, nowish. I don't know. You guys might get it done just like that, but I want to make sure that you have plenty of time, that 45 minutes. Yes.
Cool.
Any other last minute questions? Again, I wanted to make sure I give you like that crash course refresher. So what you'll need to do, go ahead and get out your MacBooks, get logged into myAP. Again, let me know if you have any questions. It should be assigned to you. It's in the progress checks. There should be one assigned, the multiple choice question project or progress check for Unit 1, Kinematics. If you need help finding it, let me know. What does it look like for you guys? So that's the login page. And go to Classroom. myAP. I want to make sure you guys all can get that. I don't know what it looks like from the student's perspective. Yeah, there should be an assignment, Unit 1, Progress, MCQ, right? Just watch later. Yep. So again, you go to myAP. I think some of you, anybody need help finding it? You log into myAP. You go to your classroom or myAP. You should be in My Class, and there'll be a spot for my progress checks. The Unit 1 MCQ, multiple choice question, is assigned to you.
I think Brady needs to join the classroom.
I thought you were in it.
I guess no.
So again, it's time. So again, the only thing you guys should have out scratch paper, pen or pencil, and then your equation sheet. Right? And once you started, it'll be 45 minutes. It's time. That should take us into class. Okay, Brody, we should be able to solve it quick. Yeah, so that would be the code that you should access It might ask you from like school information.